Smart Child Zone presents Kinetic and Potential Energy. Potential energy is the energy stored within an object, due to the object's position, arrangement or state. Kinetic energy is the energy an object has due to its motion. As long as an object is moving at the same velocity, it will maintain the same kinetic energy. There are two main types of potential energy: gravitational potential energy and elastic potential energy. Kinetic energy is the energy stored in moving objects. Stationary objects have no kinetic energy. Gravitational potential energy is stored between any two objects. So for every object on or near Earth, there is gravitational potential energy stored between the object and Earth. The amount of gravitational potential energy stored between an object and Earth depends on the mass of the object. Joel hiked up a tall mountain. He followed a trail all the way to the summit. Complete the statement. Assume that Joel's mass did not change. Think about how the distance between Joel and the center of Earth changed. The summit of the mountain was higher than the point where Joel started hiking. As he hiked toward the summit, the distance between Joel and the center of Earth increased. So the gravitational potential energy stored between Joel and Earth increased as he hiked toward the summit. Two coins are falling down a well. The kinetic energy of each coin depends on the coin's mass and speed. Compare the two coins. Use the information in the table to compare the nickel to the penny. For comparing masses, divide the nickel's mass by the penny's mass. So the nickel's mass is 2 times the penny's mass. This result makes sense because the nickel's mass is larger than the penny's mass. For comparing speeds, the nickel and the penny are both moving at a speed of 6 meters per second. So the nickel's speed is equal to the penny's speed. For comparing kinetic energies, divide the nickel's kinetic energy by the penny's kinetic energy. So the nickel's kinetic energy is 2 times the penny's kinetic energy. This result makes sense because the nickel's kinetic energy is larger than the penny's kinetic energy. These calculations match what you would expect for two coins moving at the same speed. The nickel has 2 times the mass and 2 times the kinetic energy of the penny. Read the passage about the start of a roller coaster ride and think about the kinetic energy of the roller coaster train. Which of the following is better evidence that the train's kinetic energy changed? The kinetic energy of an object depends on the object's speed. So a change in the train's speed is evidence of a change in the train's kinetic energy. This statement shows that the speed of the train changed. This statement does not show that the speed of the train changed. Ellen was training for a bike race. One afternoon, she grabbed her helmet and took her bike out to the street. She got on the bike and started to pedal, pushing hard to start moving forward. Which of the following is better evidence that Ellen's kinetic energy changed? The kinetic energy of an object depends on the object's speed. So a change in Ellen's speed is evidence of a change in her kinetic energy. This statement shows that Ellen's speed changed. This statement does not show that Ellen's speed changed. For more videos and other useful materials, visit us at www.smartchildzone.com/videos. Register your child and have access to our unlimited number of question and answer exercises. Visit www.smartchildzone.com.